Hello everyone. We are discussing about the project which I have done on the natural disaster damage prediction with the real-time data streaming. This project has been developed for real-time data streaming using the Apache Kafka and the system and the analysis to predict the natural disaster impacts which have been done or which have been going to done in the future. While moving forward in the project, we will discuss about the objectives. The project has been implement the main objective is to implement the data pipelining that utilizes the Kafka for the real-time data integration, for which we have used the disaster data types like earthquake and everything else. We will discuss it in the details forward, and we have to analyze the historical trend in the disaster impact, focusing on the total deaths which are affected populations and the total damages which are done by the particular disaster in it, and to predict the to predict the damages happened by the future disasters using the machine learning, which we have used the random forest for it. Firstly, for data generation and simulation processes, we have used the Faker library, in which I have generated the data using for particular year the disaster groups such as the hydrophysiology, geology, climatological, and biological. For particular group, there are subgroups like in the hydro group we have the flood and storms in it. For a disaster subtypes for the flood, we will get the options like the flash flood, river flood. These types of disaster will be happen in there. Then the information of the country, ISO code of the country, region, the locations and the period in which it has been happened, and the number of affected people's total damages, and the CPIs. It is done using the Kafka, which is used to integrate in it. Now, for the model training, we have used the random forest and the gradient boosting models, uh, in which gradient boosting models in which we will find the results which we'll get after the training in it as well. Now, the data which we have generated, firstly, we will see about the total deaths distribution according a number of counts and the total deaths happens in that particular disaster of it, and then the people's affected in it for a particular years. uh, Similarly, we will get the all of the data like the distribution of the different type of disasters which have happened, like disaster types which are happen, and number of disaster happens in our complete data set which we have already known in the previous years. Then yeah, it is here we will get to know that the total deaths have happened by the all the disaster in particular, like in the year 2000 we have got the deaths around 15,000 k, and around the 2019 there are little less deaths, that is there are little disasters happen in our data set which we have. Then the total deaths due to the particular disaster over the time, like for the particular, like for the flood, there are the total deaths are around the for 550 around their total deaths or in the overall data set. Here we have the total affected and total deaths in it, because the both the scales are different. Like the affected scale for a particular year 2000, that there are more than 2 lakh people affected by the disasters, but the deaths are around 14,500. The scales are the two different, therefore we are getting the intersecting graph in it, and we see the total number of total count in the particular damage which have been happened in the particular years. After that, we have trained the model using the random forest, and using the random forest in which we got the errors like the mentioned here 1047 and the RMSE 2186. For the gradient boost, it is little greater than the random forest. Here we have here I have the represented the plots for analysis of the random forest, like the true values and the predicted values which I have got from the model after the training as well, and the residual plot of the true values and the residual values. By finding the two, by using the two of the models, we have got that the random forest is working best because it has the less errors in it. Now we will see the real-time Kafka prediction plots which we have got from the model which we are while running in it. Here are some of the plots, like firstly for the particular disaster plots, like if we see for the disaster of the mass movement disasters, then for predicting from the year 2020 and 2010, we will get the disaster like predicted and actual values for it. These are the similar graphs. Below are the similar graphs which I have seen in it. It is for the insect infection disaster, and if we are seeing for a particular disaster group, then we will get to see about the predicted versus actual damages for the geographical, this one. And also for the biological disasters, there are too many disasters which we will see in the next word. Yeah, we will go to see the live learning dashboard in which we will get the predicted values. Now here in the code for the demonstration, we have used the random forest giving the best result. Then we have made the producer code file which using the Kafka, and here we are getting that the messages are getting delivered to the Kafka. We'll find the in the consumer file. We'll get to know about that. It is the normal consumer file in which we will get the real-time disaster management overall predicted versus the actual damage we are getting. It is getting updated for the every 5 seconds in it. It is the overall damage prediction which are seen the graphs in the report, and here we will get here we will get the data about the for the particular for like the dot we are getting for the dot we are getting this predicted values, and it like the values for the insect infection are not get predict not we don't get the data for that particular years. That's why we are getting the random scattered points on it. Like this is for the animal and insect. This is for the storm. This is for the landslides which are getting. This is for the mass movements, the predicted and actual values we are getting on it, and the infections results. Like we will get the updated for every the 5 seconds which are getting, and once we have to see for the consumer of the disaster groups. Here we get for like the we get by disaster group as the biological. Therefore, we will get here the biological values like for the actual and predicted values for the biological, for the geographical disasters, and for the hydro disasters, and for the other all the other disasters which are not there, like the chronological disasters. This is how it gets predicted for the that is called predicting the real timely. Once we get the data from the Kafka, which we are sending the data using the producer files for the every five in the every point 5 seconds delay. Now, for coming to the conclusion, this project successfully integrates the machine learning and the real-time data streaming, which is the Kafka, and we have done the dynamic visualizations for it also. This project can be visualized using the web page as well, like the one we will type the 128.0.1 the URL, and we will get to see that I have attached all the codes and the report and the instructions to how to install run the Kafka on it in the demonstration file. Thank you.